kiddos. Today is the Monday after Thanksgiving break. I hope you all had a great Thanksgiving break. I'm sure you're tired this morning. I am too. I feel your pain. We just got to get through 15 more school days, and then it's Christmas break. So I have a festive little Grinch hat on and a Grinch shirt. Trying to be festive every single day for the next 3 weeks of school. So expect fun little hats and things on our Google Meets. Let's fix this. Okay. So today what we're doing is our learning target is I will learn how to find inverses of matrix and determine if two matrices are an inverse. So go ahead and get out your notebook and let's take some notes. I'll try and make these as short as possible, but I do want to be sure that we're thorough so that way you all aren't confused when you get to your assignment. So for today, our title is Matrices or Matrix Inverses. And today is 11:30, the last day of November. So for a definition, the inverse of matrix A is A to the negative 1. So this is the notation for an inverse. Only if A times A to the negative 1 equals I. So A, this is your original matrix. This is your inverse matrix. And I stands for the identity matrix. So the identity matrix, if you're dealing with a 2 by 2, it's going to be 1, 0, 0, 1. If you're dealing with a 3 by 3, it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. And identity matrices can go up to like 4 by 4, 5 by 5, 7 by 7. Matrices are like, they can be infinitely big, but we normally only deal with 2 by 2s and 3 by 3s for the purposes of our class. So the way to tell if something is an identity matrix is it's a square matrix. So that means it has the same number of rows as columns. This is a 2 by 2. This is a 3 by 3. You wouldn't have a 3 by 2 or a 2 by 3, anything like that. As well as it has ones on the main diagonal. So the main diagonal is you start with your first term and that follow that diagonally. So here we have 1 and 1, then 1, 1, 1, 1. You have ones on the main diagonal, and then you have zeros everywhere else. Y'all can't see that because on the picture. You have zeros everywhere else. So that's how you know if this is an identity matrix. So what we're looking for is what can I multiply my original matrix by in order to get this identity matrix. So we're going to be dealing with 2 by 2s mainly for our purposes, but I do want to introduce this. This is pretty common. So the rule for when we're doing matrices and their inverses is if we have matrix A, and matrix A is A, B, C, D. This should look familiar from when we did determinants last week. A, B, C, D. Then A to the negative 1 is going to equal 1 over AD minus BC. So if you remember, AD minus BC, that's our determinant. We did that last week. Times, you're going to have to rewrite your original matrix. So instead of A, B, C, D, this one is going to be D, negative B, negative C, A. So you're flipping the spots of your A and D, and you're changing the signs of your B and your C. So that might be a little confusing. Once we do some examples, I promise it'll make a little bit more sense. So for example number 1, we are given A equals 1, negative 6, negative 2, and 3. So the first thing we're going to do is find our determinant. So our determinant for this one is going to be 3 times 1, 3 times 1 is 3, minus negative 2 times negative 6 is going to give me a positive 12. So 3 minus 12 is going to give me negative 9. So once I have this determinant, what I'm going to do is I'm going to put that under 1. So I'm going to have 1 over negative 9 times, and then I have to put it into this format. So I'm going to switch the places of my A and my D. So this is going to be 3 up here and 1 down here. And I'm going to change the signs of my B and my C. So a negative 6 becomes a positive 6, and a negative 2 becomes a positive 2. And then once I have that, I'm just going to scalar multiply this negative 1/9 in. So negative 1/9 times 3 is going to give me negative 1/3. Negative 1/9 times 6 is going to give me negative 2/3. 1 over negative 9 times 2 is going to give me negative 2/9. And negative 1/9 times 1 is going to give me negative 1/9. And let's see, I have run out of paper. Give me just a second here. So this is our final answer. This is a to the negative 1. So what that means is if I took A, if I did 1 times negative 6 times negative 2 times 3 times our inverse matrix, so negative 1/3, negative 2/3, negative 2/9, and negative 1/9, is that would equal our identity matrix of 1, 0, 0, and 1. So I am going to move the paper, so if you need to continue writing stuff down, please pause. Okay. So our second example. We are going to have A equals 7, negative 7, negative 3, and 3. And we want to find the inverse. So the first thing we're going to do is we're going to find our determinant. 7 times 3 is 21, minus negative 3 times negative 7 is also 21. So our determinant is going to be 0. So this is like the major rule for when you're doing matrices and inverses. If your determinant is 0, if your determinant equals 0, A to the negative 1 does not exist, which essentially means there is no inverse. So when you're doing these, and if you get a determinant of 0, you can go ahead and stop right there. That tells you that there is no inverse. So when you're doing a Delta Math assignment, there's a little drop-down menu, and it says there is an inverse or there's not an inverse. So you'll just click there's not an inverse, and that'll be your answer for that one. So when you get a determinant of 0, there is no inverse. So that one's pretty easy. And then our last example, we're going to have A equals 3, 2, 7, and 5. So we're going to find our determinant. So 5 times 3 is 15, minus 7 times 2 is 14. So our determinant is going to be 1. So what we're going to do is we're going to take our determinant over 1 times, we're going to have to flip the spots of our A and our D. So 5 and 3, and then change the signs on our B and our C, negative 2 and negative 7. So 1 over 1 is just 1. And so we'll multiply 1 by all of these. That's not going to change anything. So that means our inverse matrix is going to be our matrix that we switched locations in, or we flipped our A and our D and changed the signs of our B and our C. So this would be our A to the negative 1. So a few little shortcuts to help you remember. So if your determinant equals 0, no inverse. If your determinant equals 1, your inverse is simply going to be where you're switching your spots and changing your signs. And if the determinant does not equal 0 or 1, that's where, y'all can't see that. That's where you're scalar multiplying each term. Scalar multiplying. So for these, it is important to remember that you can get fractions. Fractions does not mean that you did it wrong. London. Sorry, I have a guest visitor today in my classroom. Fractions does not mean that you did it incorrectly. You can get fractions for these. They can be negative, they can be positive. So these are the important things to remember. Find your determinant first. That'll tell you what steps you need to take. You're going to have a combination of all 3 of these in your assignment. So there's a couple practice problems down below. So make sure you do those today. Make sure you are staying on top of your assignments. I am in the Google Meet the whole time if you have questions. So please, please, please take advantage of that. If you're missing assignments, get those in ASAP. Please email me once they are done, and I will update your grade. And since they are past due, it's your responsibility to email me, and I will update the grade. Your grades are pretty up to date, so please take a peek at those if you're unsure of where you stand in the class. So hope you all have a great day, and hope this made sense. If it didn't, please pop into our Google Meet for some assistance. I'll talk to y'all tomorrow. Bye.